Hello, so today we're going to do some practice problems for general chemistry review. Okay, so let's start with valence electrons. Okay, valence electrons. So if you recall from chemistry, from general chemistry, valence electrons are those found in the outer shell. Okay, found in the outer shell or shells. Okay, outer shell of an atom, and are responsible for bonding. Okay, are responsible for bonding. Great. So let's do some practice. Okay, should be like easy one. So hydrogen, for example, hydrogen. So there's H here. Okay, there's a shell, and it is an electron right here. And for carbon, C, okay, and then one shell over here, the second shell right here. So 1, 2, okay, 4, 5. Cool. And then you have your fluorine, F, 1, 2 shells. Cool, okay. So the first shell, this is the first shell. Yep, first, this is second shell, right? First, second, cool. Now, feel free to pause the video and would you guys give me what's the number of the valence electrons for each atoms for hydrogen, carbon, and fluorine? Okay. Cool. So for hydrogen, so we count the electrons in the outermost shell, right? For hydrogen, there's only one shell anyway, so there's only one right here, right? There's one. So your answer for hydrogen is 1. There's one valence electron. Cool. And then for carbon, so we count the electrons in the outer shell, right? So the second shell, right? The second shell, how many is there? 1, 2, 3, 4. 4 electrons. Cool. So 4 valence electrons. Then for fluorine, you count the one in the second shells, okay? So 1, 2, 3, 4, 5, 6, 7, 8. Cool. So you have 8 valence electrons in fluorine. Easy, right? Okay. Let's try this one. So do you want to finish drawing out all the electrons in nitrogen for me? Draw in all the electrons. And tell me how many valence electrons. Okay, for nitrogen, the atomic number is 7. So you have 7 electrons that you have to draw in for this nitrogen, okay? And for the innermost shell, the first shell, only can take up to 2 electrons. So you draw out those 2 electrons for first shell. And now you're gonna draw out the rest of the electrons it has, so 5. So first you put 1 in each position. Okay, so now there goes 4, and then you have 1 left, right? So you put the 1 over here. So the valence electron is 5 because there's 1, 2, 3, 4, 5 in the outermost shell, right? So 5 electrons. Cool. Not that hard, right? Okay, moving on to Lewis structure. Yeah, Lewis structure. So Lewis structure is a representation of molecules where each atom's valence electrons are specifically shown, right? Let's try oxygen. So do you want to draw out those valence electrons for oxygen? So feel free to pause the video. Okay, so if you look at the periodic table, oxygen has 6 valence electrons. So 6 valence electrons. So first, you put 4 electrons like this, and then you start to fill another 2 on it, over here and over here. And for next example, let's try the octet rule. Okay, octet rule. Simple, right? So octet rule is so covalent bonds involve the sharing of electrons between 2 atoms. So covalent bond sharing of 2 atoms for a bond, right? So a covalent bond is represented by a line between 2 atoms. Each line between atoms corresponds to 2 electrons, right? The octet rule states that atoms in the second row of the periodic table, like carbon, oxygen, nitrogen, cannot have more than 8 valence electrons. Okay? So octet rule says atoms in second row of the periodic table for example, carbon, oxygen, nitrogen, so on, cannot have more than 8 valence electrons. So let's try this one. So you have a nitrogen here, double bond to oxygen, single bond to oxygen. Okay, so nitrogen has a positive charge. So I'm going to draw out all this lone pair for you, okay? And this oxygen has a negative charge. This one has a hydrogen with it. Okay, so lone pairs on it. Cool. So what I want you guys to do is, for this oxygen, figure out how many numbers of bonding electrons non-bonding electrons and total for oxygen, and it's the same thing for nitrogen. And same thing for this oxygen. Okay, so pause the video, take your time, try for yourself. Okay, so to start with this oxygen over here, so the number of bonding electrons, so how many electrons are making a bond with other molecules? So if you see over here, oxygen is a bond with hydrogen, so which means there's 2 electrons. So to make a bond, you need, okay, you know what, this is more confusing. To make a bond, you need 2 electrons. So there's another one over here, so there's 2 electrons over here too. So in total, for oxygen, there's 4 electrons are bonded. So there's 4 bonding electrons. The non-bonding electrons are lone pairs. So you have 2 over here, another 2 down here, so total of 4 non-bonding electrons. So in total, the oxygen has 8 electrons, right? And for nitrogen, it is making a bond with oxygen, double bonded oxygen on top. So this one is 4 electrons making bond, right? So it's making 2 bonds, so it's total 4 electrons, right? And then over here is making another 2 electrons with oxygen. Over here, 2 electrons with oxygen. So the total bonding electrons over here is 4 plus 2 plus 2 is 8. Does it have any lone pairs? No. So there's 0 non-bonding electrons. So in total, you have 8 electrons. Cool. Then for this oxygen, it has two bonding electrons with a bond with the nitrogen. So there's 2 electrons. And how many lone pairs? It has 1, 2, 3. So 6 electrons are non-bonding. So in total, 2 plus 6, 8 electrons in total. So as you can see, all these oxygens and nitrogen are following the octet rule. They all sum up to a total of 8 electrons, making bonds or non-bonding. Right? Okay. So moving on, let's try the formal charges. Yeah, formal charges. Wrong notation. Formal charges. Okay, I'm gonna give you a definition of it. The formal charge of an atom can be calculated in numerous ways. Okay, the formula that we're gonna use is this one. Okay, so I'm just like Fc for formal charge equals valence electrons minus bonds, number of bonds, yeah, minus non-bonding electrons. Okay, so yeah, simple. It's number of valence electrons minus number of bonds minus non-bonding electrons. We can do this. All right, so let's try one example with it. So here's nitrogen bonding with 3 hydrogens and the chlorine. Okay, has this number of lone pairs. Okay, so first, oh wait, sorry, down here should be a methyl group, so CH3. Okay, so let's calculate the formal charge of C, formal charge of N, nitrogen, formal charge of chlorine, Cl. So it's not that hard, we're going to just follow the formula. Okay, so let's look at the carbon. And so number of valence electron for carbon, if you look at the periodic table, it is 4, right? So 4, I'm going to write down over here, minus number of bonds. How many bonds is carbon making? So if you look at this part closer, okay, so you have a bond coming down from here, a carbon, and 3 H's, because of CH3. It has 4 bonds. So the formula says valence electron minus number of bonds, right? So minus 4. And how many non-bonded electrons does it have? Does it have any lone pair over here? No, there's no lone pair, so it's 0. So 4 minus 0 equals 4. Equals 0. So 4 minus 0 equals 0. So there's no formal charge. Cool, so we don't have to do anything with it. Okay, let's get rid of this drawing. Let's see, for nitrogen, how many valence electrons does nitrogen have? So once again, look at the periodic table. Nitrogen has 5 valence electrons. So write down 5. Cool. Then minus, how many bonds is it forming? So 1, 2, 3, 4, right? So 4 bonds. And does it have any lone pair over here? No, there's no lone pair. So no non-bonding electron, minus 0. You get 1. So 1 means positive. So positive 1, right? So your formal charge for this one, positive 1. So over here we just write positive for nitrogen. Cool, easy, right? Moving on. For chlorine, yeah? How many bonds is it forming? Okay, you know what? Let's start with the valence electron. How many valence electrons does chlorine has? So periodic table, once again, you have 7 valence electrons. Okay, 7 minus, how many bonds is it forming? It has only 1 over here with nitrogen. Okay, so 7 minus 1. And how many lone pair does it have? So 1, 2, 3, 4, 5, 6. Minus 6, 7 minus 1 minus 6 equals to 0. No formal charges. Right? Cool. Let's try some of our bond line notation drawing. Remember bond line notations? Oh. right? Bond line notations. So, okay. I'll give you an example. Cool. So now do you want to draw a Lewis structure for this one? Lewis structure. And molecular formula for this. Okay, so pause the video, try for self. So Lewis structure for this one. So remember, each intersections are carbons, okay? So draw all the carbons first, your first step. So carbon, 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 carbon. Cool. And there's double bonds over here, over here, over here. And now draw all the hydrogens, right? So draw all the hydrogens. For carbon over here, you already have 3 bonds, but there's no form of charge, which means there's no non-bonding, but you have a hydrogen with it. Same goes with all other hydrogens, all other carbons. Cool. Molecular formula for this one, as you can see, it's 1, 2, 3, 4, 5, 6. So 6 carbon and 6 hydrogens. Cool. Now, let's try this one. So there's a 5-member ring and another 5-membered ring. So now draw a Lewis structure for me. Okay, so same approach. Draw all the carbons and heteroatoms. So nitrogen over here, C over here, cool. Oxygen over here, carbon over here, another carbon, connected to nitrogen. Now fill in all the hydrogens. So 2 hydrogens. 1 here. There's none over here because if there was a hydrogen over here, then we would have wrote hydrogen over here. But then since we didn't do that, which means there's no hydrogens. Rather, you can even put, if you want, you can put lone pairs with it, but no hydrogens. So 3 hydrogens over here, another 3 over here, 2. So nitrogen, same case as oxygen, there's no hydrogen, but there is a lone pair. Very good. And count the number of carbons. 1, 2, 3, 4, 5, 6. C6. Okay, so C6. And how many hydrogens? It has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Each 11. 1 oxygen, 1 nitrogen. Cool, cool.